Download this code from codegive.com, link in the description below. OK, let's dive into the world of reference phrases, also known as anchoring, in natural language processing, NLP. This tutorial will cover what reference phrases are, why they're important, different approaches to identifying and using them, and provide Python code examples to illustrate key concepts. What are reference phrases, anchoring phrases? A reference phrase, also called an anchor phrase, coreference anchor, or anaphoric anchor, is a word or phrase in a text that refers to something previously mentioned or understood. It's a linguistic link between two parts of the text, helping to maintain coherence and avoid unnecessary repetition. The goal is to understand that two phrases actually refer to the same concept. Let's break down the components. Asterisk reference, asterisk the act of pointing to something else. Asterisk phrase, asterisk a group of words expressing a single idea or element. Asterisk anchor, asterisk the starting point from which the reference is made. Example asterisk. John went to the store. He bought milk. Asterisk here, John is the antecedent, the entity being referred to, and he is the reference phrase or anaphor. He anchors the information back to John. 2. Why are reference phrases important? Reference phrases are crucial for several reasons. 1. Text coherence, asterisk they create a sense of flow and connection between sentences and paragraphs, making the text easier to understand. Without recognizing these references, the text can seem disjointed. 2. Information extraction, asterisk identifying reference phrases allows NLP systems to piece together information about the same entity mentioned in different parts of a document. For example, if we have a document discussing a product, and later it says the product is well suited for beginner, it is important to be able to link back to the original definition of the product. 3. Question answering, asterisk when answering questions, NLP systems often need to find references to entities mentioned in the question to locate relevant information in the text. 4. Machine translation, asterisk translating pronouns and other reference phrases correctly is vital for maintaining the meaning and coherence of the translated text. 5. Summarization, asterisk reference phrases play a role in maintaining entity consistency in summaries, ensuring that the summary accurately reflects the original text. 3. Types of reference phrases. Reference phrases come in different forms. Asterisk pronouns, asterisk he, she, it, they, him, her, them, his, hers, its, theirs, myself, yourself, himself, herself, itself, ourselves, yourselves, themselves, this, that, these, those, one, ones. Asterisk example, Mary went to the park. She played on the swings. Asterisk definite noun phrases, asterisk noun phrases starting with the, or other determiners that imply a specific referent. Asterisk example, a cat sat on the mat. The cat was black. Asterisk demonstrative noun phrases, asterisk using this, that, these, those plus a noun. Asterisk example, I bought a car. This car is very fast. Asterisk possessive noun phrases, asterisk phrases using possessive pronouns, my, your, his, her, its, our, their, or possessive nouns. Asterisk example, John's dog is friendly. His dog loves to play fetch. Asterisk appositives, asterisk a noun or noun phrase that renames or clarifies another noun or noun phrase. Asterisk example, George Washington, the first president, led the country. Asterisk lexical noun phrases, asterisk phrases that use similar words, synonyms, or hyponyms, more specific words, to refer to the same entity. Asterisk example, I bought a laptop. The computer is very powerful. Asterisk null anaphora / ellipsis asterisk the omission of a word or phrase that is understood from the context. This is more subtle and harder to detect. Asterisk example, John went to the store, and Mary did too. The missing phrase is went to the store. 4. Coreference resolution, the key technique. The process of identifying and linking reference phrases to their antecedents is called coreference resolution. It's a complex task that requires understanding of syntax, semantics, and context. There are several approaches to coreference resolution. 1. Rule-based approaches *. These methods rely on handcrafted rules based on linguistic principles such as pronoun agreement *. The pronoun should agree with its antecedent in gender and number. Syntactic constraints *. The pronoun should not be in the same noun phrase as its antecedent. Distance constraints *. The antecedent should be relatively close to the pronoun in the text. Example explanation we load the spaCy language model. Resolve _pronoun finds the first pronoun in the sentence. It looks for the first noun or proper noun in the sentence. It replaces the pronoun with the noun and outputs the resolved string. Limitations this example is very basic. It only handles the first pronoun and assumes the first noun is the antecedent. Real-world rule-based systems are much more complex. 2. Machine learning approaches * These methods use machine learning algorithms trained on annotated data to predict coreference links. They can learn more complex patterns than rule-based systems. Common techniques include mention detection * identifying all potential mentions, noun phrases, pronouns, etc., in the text. Feature extraction * extracting features for each pair of mentions, such as string similarity * how similar are the words in the two mentions. Syntactic features * parse tree information, dependency relations. Semantic features * word embeddings, named entity types. Distance features * how far apart are the two mentions in the text. Agreement features * do the mentions agree in gender and number. Classification * using a classifier, example logistic regression, support vector machine, neural network, to predict whether two mentions are coreferent. Example conceptual, requires more involved setup and data. Explanation this code provides a highly simplified example of a machine learning approach. It only showcases the basic steps: feature extraction, model training, and evaluation. Extract _features is a placeholder. In a real system, you'd use more sophisticated features, example word embeddings, part of speech tags, syntactic relationships. A real-world model needs much more data. 3. Neural network approaches deep learning models, especially those based on transformers, example BERT, Roberta, have achieved state-of-the-art results in coreference resolution. They can learn complex relationships between mentions without relying on handcrafted features. These models are typically trained end-to-end, meaning that they learn mention detection and coreference linking simultaneously. Example, using neural coref. Explanation The neural coref library uses a neural network to perform coreference resolution. It adds a dot extension to the spaCy doc object, providing access to coreference information. Doc_.coref_ clusters returns a list of coreference clusters, where each cluster contains mentions that refer to the same entity. Asterisk doc underscore dot coref underscore resolved returns the text with coreference resolved by replacing pronouns with their antecedents. Asterisk asterisk note asterisk while neural coref was a popular library, it is deprecated. Current state-of-the-art coreference resolution models are often based on fine-tuning pre-trained transformer models. Libraries like transformers, Hugging Face, can be used for this purpose, but require more setup and training. There are some other options available, like AlanLP, which are still maintained and can preform coreference resolution using deep learning models. For end-to-end models the current state-of-the-art usually uses end-to-end neural models. These models attempt to jointly learn mention detection and coreference linking. They avoid the need for separate mention detection steps, which can introduce errors. Practical considerations. Evaluation coreference resolution is typically evaluated using metrics like MUC measures the number of missing and spurious links between mentions. B sub 3/sub measures the precision and recall of coreference clusters. Co-NLL score the average of MUC, B sub 3/sub, and CEAF metrics. Data coreference resolution models require large amounts of annotated data. The most commonly used datasets include onto notes a large corpus of text annotated with various linguistic information, including coreference. ACE, automatic content extraction, a dataset for information extraction tasks, including coreference. Limitations coreference resolution is still a challenging task, especially when dealing with long-range dependencies when the antecedent and the reference are far apart in the text. Ambiguous pronouns when it's unclear which entity a pronoun refers to. Complex sentences when sentences have nested clauses and multiple entities. Implicit coreference when coreference is implied rather than explicitly stated. 6. Code example, basic entity linking with spacey. This example focuses on linking mentions of the same named entity within a text, using spacey's named entity recognition, NA. It isn't full coreference resolution, but a simpler form of entity linking. Explanation The code loads a spacey language model. Link underscore entities takes text as input. It uses spacey SNI to identify named entities. It stores the mentions of each entity type in a dictionary. Finally, it prints the entity types and their mentions. This code provides a basic way to group together mentions of the same named entity within a text, but it doesn't handle pronouns or more complex coreference cases. 7. Challenges and future directions. Despite the progress in coreference resolution, several challenges remain. Improving performance on complex texts. Coreference resolution systems still struggle with texts that contain long-range dependencies, ambiguous pronouns, and complex sentence structures. Handling implicit coreference. Implicit coreference, where the link between mentions is not explicitly stated, is a particularly challenging area. Developing more robust systems. Coreference resolution systems need to be more robust to variations in writing style, language, and domain. Integrating with other NLP tasks. Coreference resolution can be used to improve the performance of other NLP tasks, such as question answering, machine translation, and summarization. Future research directions include developing more sophisticated neural network models. Researchers are exploring new neural network architectures and training techniques to improve coreference resolution performance. Using external knowledge. External knowledge sources, such as knowledge graphs and ontologies, can be used to improve coreference resolution accuracy. Developing multilingual coreference resolution systems. There is a growing need for coreference resolution systems that can handle multiple languages. Creating more annotated data. The availability of annotated data is a major bottleneck in coreference resolution research. I hope this comprehensive tutorial has given you a solid understanding of reference phrases and coreference resolution. Let me know if you have any more questions.